Hello everyone, welcome back to IIM Community channel, and this is Shailaja Gupta, and today I will be discussing on predicting customer lifetime value using machine learning for non-techies. So let's start. So we would be basically predicting customer lifetime value. So see, for any company, it is very important to retain and reward the most loyal customers. And how do the lifetime value is nothing but a parameter by which you can, estimate whether a person is a loyal customer for your company or not. And what exactly it is nothing but how much money I earn from a customer minus how much I pay to acquire or retain that customer. And for this lifetime value, right, we have taken a simple framework of recency, frequency, and monetary value, which is very, very widely used in all corporates. That's the reason, we took it. So basically, your most loyal or valuable customers are those who have bought very recently from you, who keep on buying again and again, and who buy a significant amount of worth of goods from your website or app or anything. So the approach that we would be taking in this video is summarized here for your better, understanding. So first, we would be finding out the recency, frequency, and monetary value for each customer. Then we would be, dividing them into clusters. Basically, we would be grouping similar type of customers together. See, you can see here, clustering is nothing but, you're grouping similar things together. Segmentation based on clustering is, so basically, we would be like you can see here, red, green, blue, right? Now we have segregated them into different clusters based on similar type of things being grouped together. So what we would do here is we would be grouping similar type of customers into one group. Okay, we will get an overall score for each customer, which will be based on all these RFM parameters. And then we would be labeling overall scores as mid, low, and high customer lifetime value. And once we have these scores, right, of high, low, mid, customer lifetime value, then we would be training and fitting a machine learning model. And once we have a machine learning model, we would be predicting the future customer lifetime value based on this ML model. Now we go one by one. So the first step was find out the recency, frequency, and monetary value of customers. So first we attack the recency value. Recency value is nothing but how recently this person has bought from me. So what I would be doing is, let's say, the last transaction in my company was yesterday. So before yesterday, how much time has passed between the last transaction and this person's last transaction? That would give me the recency value. I will explain that to you. See, for example, you can see here, this customer 111 has transacted on 4 dates. And the maximum purchase date, right? The most recent purchase date is 18 Jan for the 111 customer. For 112, it is 7 Jan. For 113, it is 18 November, and so on, right? You can easily see from here. So basically, I am just trying to understand what is the maximum purchase date for each customer, and then this recency value will be based on the maximum purchase date in the entire data set minus the maximum purchase date for a customer. For example, here you can see the maximum purchase date for the entire data set is 18 Jan 2011. Okay, for the 111 customer. Don't confuse it with this 113, that is 18 Jan 2010. Okay, so this is the most recent date is 18 Jan 2011. So the recency score for 111 customer is 0. Okay, for 112, it would be just subtract these two dates. It is coming 133 days, and for 113, it is 365 days. Exactly 365 days before was this 113 customers last transaction, most recent transaction. So this is what we are trying to do. Okay, this is what is written by the recency value. And once we have the recency values, right, we are going to divide them into clusters. For example, you can see that this person 111, has very recently, just yes, the last transaction was by this customer only, so he will be in a different cluster. Then 113 has transacted 1 year back, he's in a different cluster. 112 has transacted maybe in the middle of the year, he's in a different cluster. Let's say there is one more person, 114 customer, who has transacted on last transaction, the recency score was 10. Basically, the last transaction in the database minus his last transaction, the difference is 10 days. So he would also be in cluster number 3. So similarly, we are going to group, basically based on the recency values, we are going to group customers into clusters. So that was it. Yeah, so this is nothing, I mean, recency is just, it is showing when was the last time the customer bought from us. Now to get to this stage, right, you need to code. So I have written down the codes which you can directly use, with some tweaking here and there. For example, what we need is, this is the data set, you have the entire data set which is given here. You need to find out the maximum transaction date, purchase date for each customer from this table. So for 111, the maximum purchase date is 18 Jan 2011, which is shown here. So how will you find out the maximum purchase date for each customer? For that, you can use this code which I have written here. Okay, tx underscore user is nothing but this table name, the transaction table name. Okay, so we have just grouped by customer ID, and we have taken the maximum of the invoice date, and that's it. Okay, so you can just directly copy paste this formula, and you can change tx underscore user is the name of the database which has all the transactions. But if your table name is something else, let's say its name is transactions, and you will change it, you will change the table name accordingly. That's it. Otherwise, you can use the code as it is. Once you have, now this will give you, the first step will give you the maximum purchase date for each individual customer. Now you need to subtract the last transaction of the data set with the last transaction of each and every customer. So the last transaction of the data set you can easily get by the max of this max purchase date column. So that is exactly what I have done. So you can see this whatever dot max, I mean the first thing which we are subtracting is the maximum transaction date for the entire data set, and we are subtracting that with each and every individual maximum date for each customer. For example, for customer 111, we will be subtracting 18 Jan 2011, which is the maximum purchase date for the entire table, with his maximum purchase date, which happens to be the same. So the score will be 0. For 112, we will be subtracting 18 Jan 2011 with 1 June 2011, and the difference we are getting is 133 days, and 113 we are getting the difference as 365 days. So something like that. And once we are done with this, we now want to club people into different clusters based on their recency values. For that, what you need to do is clustering. So clustering, like you saw earlier, right, it was nothing but you're grouping similar type of things together. That is exactly what clustering is. One of the ways to do that clustering is k-means. It is one of the algorithm by which you can do clustering. There are multiple other algorithms. I've just used one. Okay, so you just copy paste this code as it is. Just change the tx underscore user to your data frame. That's it. Everything else you can use the same, and you will get something like this, some graph that you see on the right side, right? And what you do is, now this graph, what is it telling me? It is telling me, see, now clustering is nothing but grouping similar type of things together. Like here you see there is blue, green, red. So you know that there will be 3 different clusters in here. The first figure you see blue and red, so it is 2 different clusters. In the second figure you see there are 4 different clusters. So how do I know how many clusters we need to create? Because for people, you cannot know beforehand how many clusters we should create. So this graph will help you to do that. You see this graph, when it starts, the steep decline stops, and the line starts declining but at a lower pace. Then that is the point where you understand that this is the number of clusters I need to take for my algorithm. So number of clusters here is 3. See, after 3, the decline has become less steep. So this number of clusters will be 3. And so you just take that. Okay, you take the number of clusters equal to 3, and then you use k-means dot fit predict, that this is a function name, and you put your recency value, recency column here. Okay, it will predict which cluster type each person will belong to. So the first 111 belongs to cluster 3, 112 belongs to cluster 2, 113 belongs to cluster 1. Let's say there is a 114 customer, okay, whose recency value is 10. So it is very likely that he would be in cluster 3. If there is a 115 customer ID and whose recency value is, let's say, 400 days, then he would be in cluster 1, and so on. Okay, so basically the cluster 3 is the most recent people are in cluster 3. The least recent are in cluster 1. Okay, in this particular case. Okay. So 1, 2, 3 cluster is nothing but just a cluster label. Okay, that's it. It doesn't mean anything. But here in this particular example, cluster 3 is the most recent and cluster 1 is the least recent. Now, after you have done the recency, we need to understand the frequency. How many times has a customer bought from us? This is also very important to understand how loyal that person is and how much we should try to retain that customer. Now, for the frequency value, we need to find out the frequency of transactions of the customer. And for that, I have just done this. I mean, it's a simple calculation. I have just counted the number of times he has transacted, group by with customer ID, and then count the number of dates in this particular case. Okay, yeah, so here here we are assuming it's a simple data set where one person transacts only one time in one day. Okay, otherwise you, instead of counting the invoice date, you could have counted the number of transaction IDs, if it's a like real time database, whatever. So you understood, right? We're basically counting how many times a person has transacted. It is simple, there is nothing in it. It's, you can see it here. And again, so here we are again applying the same, k-means. You see that, after the third cluster, the decline is less steep. So we are taking n is equal to 3. And here also we will get different cluster names. Again, this is the exactly same code. There is nothing that I have changed. Only instead of tx underscore user, frequency, recency, we have just made it frequency. That's it. Everything else is same. So we will get frequency clusters. Okay. And we will get frequency clusters. So 111 is the most frequent. The most frequent people are in cluster 3. The least frequent are in cluster 1. Okay. According to this example that you see. So 111 has transacted the maximum number of times, 300 times. His cluster is 3. And 112 has transacted 150 times. His cluster is 2. 113 has transacted 12 times. His cluster is 1. Now you have monetary value. So how much is the shopping by a customer worth? So for monetary value, we need to find out the monetary value of the transactions of a customer. So for monetary value, it is simple. The same exact thing we will do. We will group by customer ID and we will find the, sum of the total monetary value, that a person has, how much total sum of revenue he has spent in the, company or the website or the app, whatever. Now, the thing is that, see, in real time data, you are not going to be given revenue directly. You will be given, price and quantity, let's say. So I have just done nothing. We have just multiplied the two columns. Okay. And we have got a revenue. And then we have just applied a group by, which you can see here. Right. So you can directly use this code again to get the, cluster, to get the revenue, basically grouped by revenue. So basically for customer 111, you will have, the total of revenue. It is 2532. For 112, it is 132. For 113, it is 500. Okay. Now, the same exact thing we are going to do, the same exact code that we used earlier, okay, for finding out the how many clusters should we, consider. So we again find that, we should consider n equal to 3. 3 number of clusters for classifying people into different revenue clusters. Okay, so we have classified into 3, 1, 2. 3 is the maximum revenue, 1 is the least revenue. Okay, so like that you will have a revenue cluster for each person. Now, the final scores will depend on the overall parameters of decency, frequency, and monetary value of the customers. All three combined is going to give me the overall score for a person. Okay, so basically I have kept the weightage as same for all the three. Okay, so the thing is, you can change the weightage. You can, give maybe more weightage to revenue, maybe less weightage to recency, whatever. You can change the weights. Okay, but I have taken all same weights. So like that, we will be getting the revenue clusters, frequency clusters, and the recency clusters. The overall score is nothing but it's just the sum of the recency cluster. So for the first person, 3 plus 3 plus 3 is 9. For the second person, recency cluster 2 plus 2 frequency cluster and plus 1 revenue cluster, it is 5. For 113 customer ID, it is 1 plus 1 plus 2, which is nothing but 4. Okay, so overall score we are getting like this. And then we have just, defined a business rule according to our, this is completely based on business logic. Okay, so if the overall score is greater than 3, then, keep it as low value. If it is greater than 6, keep it as middle value. If it is greater than 9, keep it as high value CLTV. So like that, now this is the, let's say, the final data frame that we get. So for 111, the segment is high value. For 112 and 3, it is, low value. For 114, it's just, I have just added an extra one to, include a middle value CLTV, and the segment number, because the machine cannot understand high, low, middle value, right? So I have just, converted into some numbers which machine can understand, 3, 1, and 2. Okay, so what we need to do now is we need to make sure that the machine is able to predict for any new customer. Now, what we need is that this machine learning model should be able to predict the customer lifetime value. So for, let's say, the first customer, 111, we have some input variables, IV 1, 2, 3, 4. I mean, it could be anything. It could be age, income, gender, whatever, city, anything. It could be any information about that person. Then we have the recency cluster, frequency cluster, revenue cluster. We have the overall score. And based on all of this, we have, a segment number. Okay, we have some segment number also. Now what the machine learning model should be able to do is it should be able to understand that, okay, for this person, these are the type of input variables, and based on that I'm getting some segment number for the CLTV, 321, whatever, high CLTV, low CLTV, middle CLTV, etc. And similarly it can understand that these are the type of people, these are the characteristics of the people who have high customer lifetime value, these are the characteristics of people who have low customer lifetime value, and so on. So like you can see in the graph below, so machine learning is nothing but, it is plotting all these X variables, input variable 1, 2, 3, 4, recency cluster, frequency cluster, etc. This is the X axis, okay, the input variables. And the Y axis is going to be the segment number 312, which is my target variable, which I'm going to predict using this machine learning model. Now you can see it's just XY, and there are so many X's, right? There is input variable 1, 2, 3, 4. So in actuality, there will be multiple X axes in the space somewhere, and based on that, basically we will be predicting the Y variable. But I really want to keep things simple, so you can just assume that if there was just one X, based on which we were predicting Y, then what we can do is we can just pass a line through all these dots, and this line is going to be the machine learning model. It will not exactly fit each and every point, but we are trying to just make some kind of a function, which is the machine learning model, the blue line that you see, which can predict at least most of the points with a decent enough accuracy. Now, we are trying to use machine learning to predict the customer lifetime scores for each of these people, right? For that, you can just use this code directly as it is. It is just going to predict it. It's doing nothing, but it's simply predicting the customer lifetime value for the new people who come. Okay, so your X train is nothing but your transaction data frame from which you remove the segment number, because this is what we are trying to predict. The thing that you're trying to predict is going to be in Y train and everything else will be in the X train. Okay, and you are trying to predict what should I say? You're trying to predict what would be the segment number for the new customers whose information you get. Let's say there's a new customer, 200 customer ID, okay, and you have all the information about the input variable 1, 2, 3, 4, recency cluster, frequency cluster, revenue cluster, which you have calculated. Overall score you have. Now you need to predict what will be the segment number for this new customer. So you can do it using this one. Okay, there is something called so this what we are doing is xgb classifier. Now this line is calling a function xg boost. It's a machine learning model, and you just have to fit your see. So this XG boost is, it's a machine learning model which you're calling to predict this customer lifetime value. You are just calling a dot fit function. Basically, you are just, training this model using your X and Y input and output variable. You're training the model as in you are teaching the model, which type of people are in low customer lifetime value, which type of people are in high customer lifetime value, and so on. Okay, for the basics of machine learning, I will be, there is a machine learning basics video which you should see. I will be just, posting the link down somewhere for the same. Okay, so basically you will be fitting the model. You will be training the, model first to understand which type of customers are likely to be in the lower customer lifetime value, which ones are likely to be in the middle customer lifetime value, which ones are likely to be in the higher customer lifetime value. And then you will be just calculating the accuracy of this model. You see that it is very accurate, 95% on training and 92% on test set, which is very good actually. And then you are going to predict using this model for any new customer who comes. You can easily predict using this code, what would be the customer lifetime value for any new customer who comes. You can directly copy paste this code as it. So let's look at a basic summary of whatever we discussed right now. So first we found out the recency, frequency, and monetary value for each customer. Then we divided similar type of customers into, the same type of clusters or groups. We got an overall score for each customer, and we labeled the customer scores as, high, low, or middle CLTV. Then we trained and fitted a machine learning model, and we are now able to predict the future CLTV for any, new customer that arrives. And with this, I come to an end of, predicting customer lifetime value using machine learning model for non-techies. I hope you like the session. Please let me know. Thank you.